accepted, challenge accepted. Reality is always challenge accepted. Challenge accepted, challenge accepted. Reality is always challenge accepted.
Our next topic is one of those things every automation engineer complains about, but not everyone talks about enough.
Test data. Because no matter how shiny your framework is, without good data, your automation is just a very expensive clicker.
The next talk is all about making test data reliable, secure, and CI/CD friendly.
And our speaker knows exactly how to make that happen. He started his career at Telerik Academy, grew through the QA ranks, and became a principal QA engineer, trainer, and consultant.
He's now a test automation consultant at Automate the Planet, helping teams replace boring manual tasks with smart, repeatable automation.
He shared his knowledge on stages like TestCon Europe, QA Global Summit, SelenumConf, and of course, QA Challenge Accepted.
He is passionate about teaching others and proud of the many automation engineers he's mentored along the way.
He is also one of our proud nominees of QA of the Year Award. Please welcome Nikolay Avramov!
Is this working? Can I get the mic to work? Okay, that's great. Thanks for the intro. You got my name right this year. Thank you. Let me do the quick setup. Extending. Good one. Yep. Show presenter view. Okay. Perfect. All right, thanks for having me. As you all heard, my name is Nikolay Avramov, and I'm a technical consultant and director in Automate the Planet. I'm super happy to present this in front of you today because this was a talk I was delaying quite a bit. Because test data is something pretty big, and I really wanted to get enough context and enough experience with different projects so I can really wrap it up and show it in front of all of you. It's not a talk just about different strategies, pros and cons and evolution, but also I'm gonna try to give you some useful tips and actual product that you can use in your projects that I spent some time to build, so hopefully it's gonna be pretty helpful for you. This talk, I hope, will serve you as a roadmap, so in your daily work, you can see where you're at in the evolution of the test data management strategies and how to get to the next step, of course, if that is needed. If you don't have issues with it, that's perfectly fine. And this is the kind of, speaking of different types of talks, this is the one with the hands. So please use your hands if you find yourself in any of these strategies and help everyone understand how many people are using them or not. Also, this talk, as you see the picture, is inspired by my son's favorite cartoon, Asterix and Obelix. I'm really curious to see with hands how many of you have heard of it or have seen it. Okay, that's good. That's a good number. Okay, so you probably know the story. The action happens in the small village called Gallia, which refuses to be defeated by the Roman Empire. It kind of reminds me of our national volleyball team, who are, as we heard, now fighting for the gold medals in the World Championship. So with this metaphor, I will move forward with the universal challenges of test automation. Getting a step back, when we start in a project, we always look for the people on the shield that are basically guiding the team into a different direction. And when we ask them, what are the problems you face, what are the issues your team have related to test automation, we often get some of these. Test flakiness, execution speed is too big, we don't have any autonomy of the tests, lots of false positives, meaning lots of maintenance, and the worst of all, false negatives, meaning that we have lots of automation and we still get issues along the way. Looking at the business perspective of this, that means they're losing lots of resources on maintenance, where they're getting slow feedback from their tests, and they're wasting lots of time on analyzing their runs. The false negatives, of course, are meaning that critical issues and defects are reported by clients. So that's a pretty bad thing. But when we look at all this and we start sniffing around in the project, see what was built, we find a couple of issues that some of them are easy to fix, others are not. Fragile locators, that's something everyone's facing. Static weights all over the place, meaning that we cannot react to slower environment. We get lots of end-to-end BDD tests. That means everyone is going with behavior-driven tests, written in Gherkin syntax, and they're trying to create their data and everything using the UI. Reporting and analysis is also a big chunk, but it has ways to improve it quite easily. But in all of this, you can find traces of the missing test data management and overall strategy about how to build it. Because all of these can be achieved and can be improved with a better test management strategy. So that's why we find that test data management is not a problem, it's the biggest problem that we see in most of our projects. So let's move to the evaluation of test data strategies. You're going to see different approaches, starting from the lower level to the higher end. And the bad thing about not good enough test data strategies is that they work for some time, you get some rocks over there, but at scale, they start to fail, and you have to rebuild the whole thing. So the later you are in this process, the more painful it is to rebuild it. So, starting up with the first strategy. I call it the naive approach. That's why I have Obelix here, who's always willing to help. He's pretty powerful, but he's not on the long-term thinking. So what is this method? It's basically using the existing data from the database. We just go there, use whatever it is, write our automation scripts. They pass locally, do one run, and we commit the code. The benefits, quick implementation. Just go there and do whatever is needed, and your job is done. You get the story points, it's all fine. So where the problems comes? There are plenty of them, I just listed 3 of them, but these conflicts start to appear between different tests. We get environment issues, we get unpredictable test outcomes. So all this flakiness, all these timeouts, everything's come together. So how many of you have tried this, at least when you're starting your journey? Can you raise hand? Yep, when I teach at the academy, we always start, no matter of the age of the participant, we always start automating stuff. And this is the first thing everyone is doing. Let's agree with that. And that's perfectly fine. So that's the first step. Moving forward, we decide that instead of relying on existing data, we can produce the data ourselves. So we can arrange our army in the test environment, we can set everything up that we need, and when our tests start, we can get the data and just use it. That's perfectly fine. And this strategy works. It could work for many years, and we have seen that in some projects. So where's the issue with that? The issue comes when you want to run on parallel, when you want some independence from the test, so you need some flexibility in the test. You start to get some data corruption, which basically erases all your data and you have to recreate it. Or even if you decide to store a backup and then restore it every night before the test come, at some point the knowledge about how this test data was built is starting to disappear. It could be a colleague that is on leave that was creating that entity you need. It could be someone that's no longer in the company that produced the data. So if something happens with that data, what can you do with it? How to produce it? So that breaks hardly, and you have to go back to the drawing board and you have to rebuild it. What is the next step from the strategy? Actually, let's check how many of you have tried this. Okay, it's not a huge percentage, meaning that all of you are doing a great job. Getting to strategy number 3. I've got asterisk here. He's quick and easy, and he's very fragile. So this is the next approach where you decide to scratch all the data that's in there and start producing it yourself. So you find the API, the database that you need to use to produce your data. You generate it, and then every test can use your data. That is independent, that does not exist because of another test, and that allows us to do many more things with our tests. At some point, you start seeing that your tests are getting more and more useful. People start asking, what are the results? Devs want to ask you to start your tests on their environment just because you can, using that approach. And that's great. That's the point you see you're doing your job well. The challenge. When the project starts to get bigger and we have more and more complex entity relations, these projects, they are still code, and you have to manage it some way. So if you create data with one API, you start adding methods for everything you do. So this whole project becomes a bit messy and hard to maintain. So with complexity, the issue comes, and you have to find a better solution, better architecture and strategy, how to achieve it. And this is the point when you have to turn your big, powerful beast on the left to the more structured and agile thing on the right. That's why we implemented a solution we call a model-driven solution. The core architecture of it is basically getting models to represent the data. So we can combine and collect everything we have in our project depending on the scenario we need to achieve. Having this generic approach and setting and coding the entity relationships between models enables us to scale and basically incorporate this solution into any problem we have with this data. So we get to the next point when you need it in a large scale. In order to represent it in a real world, I'm using this Trello board. Probably most of you have heard of Trello. This is a very simple task management system. It consists of a couple of items. We have the board, we have the lists, and inside the lists we have these cards. So this is a typical representation of dependencies. The cards relate on lists and list relates on boards. Pretty simple. So how do we build this foundation? We start with the models, as I said. Define the relationships, see what are the dependency chains and how they relate to each other. Can one live without the another? Later on, we create the models themselves as classes. Could be Java, could be C# or anything else. And then we introduce two entities, two classes that help us to achieve all of that. The first one is the factory. Factory it has single purpose, and it's meant to just build a default thing, a default model that can be sent directly to the database. That's everything it does. The next one is the repository, which knows how to create, update, or delete data. This is all generic, so you can use it for any models. These two you can imagine as if you're making a bread. So when you make a bread, you mix the contents, you leave it aside, and you get some dough. So after you have it, you can make any shape of it. You can make it any type of bread, but then you have to bake it. So we are separating these two processes in order to achieve maximum flexibility and to achieve the test scenario that we need. So how do we use all of that? Let's see one of the simplest test scenarios here. We just need existing card in order to update it. But that card actually depends on the list, and the list depends on the board. So how do you get to the card actually? You have to create both. So what we're doing is we're building default models across the whole dependency chain. You adjust the data that you need, no matter if it's on the list, on the board, or the card, and then you create the entity in the database altogether. Then we navigate to the page, and you get a data that is fresh, that's adjusted to your scenario, and you don't have to worry about it. For the test scenario, of course, we can take any of these and use them. So after we're done with the test, usually there is a mess that needs to be cleaned. If we use the approach with the golden set, of course, we can wipe up the database. But here, this is not required. We know what data we created, so we can keep track of it. And after the test finishes, we can go ahead and delete entity by entity everything using the repository because it knows how to do that. Cool. So having all of this, it looks like we have some flexible approach, and we can start shaping it according to our scenario. Now we can try to face the big battle. So we might wonder what's the secret sauce behind this. I prepared a really short demo. Hopefully it's going to be presented here as well. Let me see if that works. I'm going to duplicate. Okay, I got it. So a brief intro. This is a Java project, obviously, built on top of Bellatrix, but I have spent some time to make it possible to extract it because we have it as a module, and this can be built into any project. So looking at the code, we have a very similar approach for the different entities we had back on the slides. The board, which is the model we use, the repository, and then the factory. Using some hierarchy that we built into this project, we're keeping all these super simple and keeping their duties really limited to what they're intended to do. The model has just a couple of methods that we need for the whole infrastructure to work, and inheriting a base entity. The board repository, the one that knows how to create, update, delete, has been built here. All the logic is inside of the base classes, and you just do the stuff, you override the stuff that is specific for that endpoint. In this case, you cannot delete a board, you have to set it to closed, and that's perfectly fine. The refactory itself, it has just one method that's required. It's supposed to build a default model that we can send directly to the database. So that's all we have. When we create a card, we need the rest of the models created. So we have to incorporate these dependencies between models. How do we do that? We just create one field that is of type list or whatever entity is the dependency, and we denote that this is a dependency, so we cannot create this model without it. This way, the module knows that it has to create the other one first, and this is how the whole thing works together. Looking at the test, I'm going to show you how this is benefiting your tests. So, when you start one test, you're just calling the factory, using the card factory. I want a default card. At this point, this is not created in the database, so we can adjust it. Then you call the method create with dependencies. It's being created through the database with the default data. So I didn't say that I need a board, but it knows because the models are built that way. After that, when I assert, I can get from the card to the list, to the board, and then get its ID and verify it. So that flexibility is super useful when you have complex scenarios. And the whole idea actually with these dependencies started from this: how do we clean up the data? So when you have these dependencies, as I said, you can call one method and it goes all the way through the chain and it's cleaning up everything it produced. Cool. So when you want to modify stuff, you can just produce your data, get it from the factory, set your properties depending on the scenario, and create it. And as you can see, this is not a web test. This is more closer to the API test, but it's not. And I built it like that because this one can be reused in either API tests, desktop tests, mobile tests, or web tests. With this module, you can power all these different testing types. So we have also example for web tests. I'm gonna just briefly show you. Getting to the boards. So it's basically the same flow. The difference is that instead of hard coding some stuff all over, you have to produce your data and just use it in your web test after you navigate to the scenario. So this is a public repo. I created it for you, so you can use it and take a look after the lecture. Let's move back. Extend. Oh God, again. Getting there. Cool. So you might think this is a bit of an overkill for such a small project. It's 3 entities, I can create them right away. It's not a complexity. But this is a picture that I really like. This is a real picture from one of our projects. And everything you see, don't try to read it, it's blurred. Everything you see, every single line, is representing an entity that is connected to another entity in the system. So we built this on top of our models that we built in the project, and we used an external tool to draw this graph. So when you have that complexity, what else can you use? Any of the other approaches simply won't work. So, getting to this, what do we get after we implement such approach? It's even better if you have it from the beginning, but if you implement it, you get great configuration management, it's environment agnostic, data isolation, all of this has been done. You can optimize your API calls so you don't create it every time, or reuse it, or whatever you want, basically. The maintenance and debugging has been significantly reduced. We're talking about 15,000 regression tests, but not manually, automated. They run from 24 hours, and we have to give feedback from these results basically every couple of days. So in this scale, anything else is pretty much impossible. It has integration with the Bellatrix framework, but I believe it can be built with any other framework as long as it has proper architecture in place. Metrics, stability, execution speed, all of this you have control of, and also this all makes sense to developers because they use similar patterns and approaches in their production code usually. You can get the model-driven solution from this GitHub repo. I'll keep the slide just for a second. I try to produce some documentation and give you a getting started guide. So if you have questions, always you can ping me for this. And that's pretty cool, I think. But it sounds a bit 2024 to create your models, to create your repositories, classes, and all of that stuff by hand. After all, it's the year of AI. So the example I built, I used Cursor and Rucot to help me with this example that I showed. What did I do? I didn't ask Cursor, hey, let's create some test data management solution that works for everyone across the globe. I had everything in my head. I had the module, I had the documentation. So it was about providing the right context to the model so it can build the entities the way I wanted to be created. The relationship detection, the customization, most of it came from the model, but I gave it the open API document specification for that endpoint, and it figured it out from that context. Without it, it would be pretty hard to get. For anyone who wants to try it out, I produced this root prompt that you can use. So it will get you the whole structure of the project according to the use case you have for any API, at least on theory. So now we have something even better. We can start kicking butt with this approach and basically get your automation projects out of this world. In summary, not having test data strategy is not good strategy. Different strategies hide issues along the road, so you have to plan and you have to be informed about what's ahead and where you're staying in the moment. It's perfectly fine to use a simple approach if you don't have that scale, but if you plan to do, it's better to have it in mind. Implementing flexibility is paying off big time after a couple of years and after some time goes. And AI, of course, is here to help, and we should use it for the right things. So we can generate the boilerplate code and focus on the test scenarios we have. Thank you very much.
Thank you, Nikolay. Thank you very much. Do you have time for questions now?
Sure.
Quick two questions, yes. Mic here for our friend.
Good, because I have two questions. No, I'm actually joking. I wonder how you deal with injecting data that you cannot simply generate and put into a database. Just to give you an example, so if we have data that you need to encode and you don't have access to keys to encode it because of like security reasons and you don't want to expose it. Or another example, you have a service, internal or external one, that must process data and then only then inject it into database. So you cannot just directly put it into database. How do you deal with this?
Yeah, that's a great question. I actually had a slide about this, but wanted to keep the storyline straight. So basically, you have cases when you cannot produce your data, and that's the usual case because you work with lots of third parties. And this is the place where mock data comes in. So you want to create some mocks that simulate an API or external service that is producing the data. I can share the risk that I have seen using this approach, and that data, the data structure and responses change with time. So basically, if you keep it static, keep your mock, you can miss some issues just because the data has changed and basically you're not reacting on it. So does that answer your question? Okay, yeah. Mocking is a valid approach in test data management.
So thank you very much. Is there any other question for now? There's one raised hand. Last question for here. The other question will be asked in the speaker's corner.
Hi, hello, my name is Damante, and I have a question. If I've understood correctly from your presentation, is that you encourage to use that data regeneration and then cleanup over storing the same and the same data, right? Mm-hmm. So do you have a solution for then regenerating data is taking too much time and slows down the tests, mm-hmm. but also reusing the already existing data is not sufficient because it can break other tests as well?
Yeah, that's also a good question. Usually when you deal with a big system, you have to draw a line between data that should stay and data that we need to produce. These are the so-called nomenclatures or enumerations. These are configurations on the system that should stay. So if you produce everything on the system from scratch every time, it's obviously get really long. So what we usually do is we draw a line. Where do we stop creating? And we rely on existing data that is needed for the system to function. And what data we produce ourselves. So this is a dynamic process. It's different for every project, but yes, it's needed, because if you create everything from scratch every time, it's going to take lots of time. Yep.
Thank you very much. You received T-shirt. You received T-shirt. You can ask your organized questions in the speaker's corner, where Nikolay will be waiting for you during the next break, which is your...
My favorite break. This is a lunch break.
Let's send off Nikolay with a big round of applause.
Applause.
Nikolay Avramov.